Hello students, welcome to JCE Connect series of lectures. So in previous class we have derived the equation for broad crested weir, that is a discharge equation we have derived for a broad crested weir. That is this equation we have derived. This discharge equation we have derived in previous session. Q equal to 1.705 into CD into L h raised to 3 by 2. That is if we substitute the value of h, this value after differentiation with respect to small h, if we differentiate this term, then finally we get the h 2/3 of capital H, that is head over the crust of the weir. If it is 2/3, that is 2 by 3 times the capital H, then the discharge will be maximum. If we substitute this value in the above equation, we get finally this one. So here this is the simplification. You please go through this one and you just write it down and check the answer here. And even you can write, even if you substitute, if you consider the velocity of approach, then this h get changes. That is h will become q equal to 1.705 CD L. In place of h you can substitute h plus HA. If you take h plus HA raised to 3 by 2 minus HA raised to 3 by 2. This is the change in the equation we get if we consider the velocity of approach. Okay, as you know the velocity of approach. Okay, the velocity with which the water approaching the weir is called as a velocity of approach. Because of that one, there is a slight increase in the head of the water. That slight increase can be written, that is h plus HA raised to 3 by 2 minus HA raised to 3 by 2. I hope you understood this one. Then let us just calculate the discharge over a narrow crusted weir. Discharge over a narrow crusted weir. As we know the definition of narrow crust based on the B by H ratio or L by H ratio, if it is less than 0.625, it is called as a narrow crusted weir. See, look at the picture here. The crust is narrow here. For narrow crusted weir, that is 2L, that is width you can call it, or it is called as a length. If it is less than H, that is head over the crust, and it is similar to a rectangular weir or a notch, hence Q is given by. Since the flow over the narrow crusted weir is similar to a rectangular weir, hence the discharge equation can also be given as Q equal to 2/3 into CD into L into root of 2G H raised to 3 by 2, means similar to rectangular weir. Okay, the ratio B by H, or you can call it as a L by H. If it is less than 0.625, is called as a narrow crusted weir. And one more is a discharge over an Ogee weir. Even it's a narrow crusted weir. Okay, narrow crusted weir, that this is not the 0.625. If it will be so for narrow crusted weir, the crust is narrow like this. Okay, the water is flowing like this, and P by H ratio, or it is in between 0.625 and 2.5. Okay. Next is the discharge over an Ogive weir. Actually this is a narrow crusted, means the crust will be like this. By mistake it is, the picture here is it's a sharp crusted weir. Okay, the narrow crust will be like this. Okay, and this is B. This B by H ratio is in between 0.625 and 2.5. Then as we know the Ogive weir, Ogee shape figure shows an Ogive weir in which the crust of the weir rises up to a maximum height of 0.115 times the capital H. Means if you take this as a crust, top portion of the weir crust, above the crust the water height is H, and above this one, if you take, this is rising. See how much it is rising, 0.115 times of H. It is design is like this only. So 11.5% of head, the H is the height of water above the inlet of weir, and then falls down. Okay, the discharge for an Ogive weir is the same as that of a rectangular weir, and it is given by same equation as previous. See, 2/3 of CD into L into root of 2G H raised to 3/2. Means the flow of water over the Ogive weir also same as rectangular weir, hence the same equation can be used. Okay, this is the picture of Ogive weir. Suppose in exam if they ask about the Ogive weir, you draw the figure, mention the height, that is the rise above the crust will be 0.115 times of H. Okay, so as I explained the previous class, generally Ogee shaped weirs are provided for the spillway of a storage dam, and the crust of the Ogee weir is slightly rises, and it falls into a parabolic. Ogee weir is also similar to flow parabolic Ogee weir, and Ogee weir is also similar to flow over a rectangular weir, and a reverse curve shaped it will be reverse curve shaped like an elongated S shape. If for the water falling like this, it is elongated S, means reverse S. Then the downstream faces of overflow spillways are often made of this shape. And here, if the space below the nape, this is the nape, it is filled with masonry or a concrete, and the consequent weir formed is called as a Ogee weir. Okay, and the discharge over a Ogee weir can be calculated by using the same formula as that of rectangular weir. Okay, so let us solve some problems, taking some numerical problems here. Let us take the first problem. A broad crusted weir of 50 meter length has 50 centimeter height of water above its crust. Find the maximum discharge. Take CD as a 0.6 and neglect the velocity of approach. If the velocity of approach is to be taken into consideration, find the maximum discharge when the channel has a cross-sectional area of 50 square meter on the upstream side. So this is the problem given. So let us take or write the given data here. So here the given data, the length of the weir, that is L, is given as a 50 meter. Then the head of water, this is given as a 50 centimeter, and the CD value is given as a 0.6. Then neglect the velocity of approach. It is mentioned, if you neglect the velocity of approach, the equation will be simply this one. Just look at this equation. Maximum discharge is given by 1.705 to CD into L into H raised to 3/2. This is the equation we have derived previously. Substitute all the values given, then finally the discharge we get as this one. If we take into account the velocity of approach also, if we take the velocity up approach, as we know, the velocity can be calculated by using the formula Q equal to A into V. V becomes Q by A, and area of channel is given as a 50 square meter. Calculate the velocity of flow, then we get a velocity of flow this much. Then calculate head to velocity of approach, that is by using this formula H equal to V square by 2G. Substitute all the values, we get the head. So this much additional head we get because of the velocity of approach. Then the Q max will become, so just modify this equation. You modify this equation, that is the additional head we are getting because of the velocity of approach. Substitute that one, then we get H plus HA raised to 3 by 2 minus HA raised to 3 by 2. Substitute all the values in this formula, we get the final answer as 18.412 meter cube per second. So this type of problems means simply you need to remember the equation for the discharge and substitute all the given datas. So sometimes they may ask you to consider the velocity of approach, or sometimes they may ask you to neglect the velocity of approach. So depending upon the statement of the problem, or what actually you need to calculate, based on that you need to apply the formulas and get the answer. So this kind of problems are very simple and straight. You may get in exam usually 8 to 10 marks this type of a problem. Okay, let us take a next problem. So move to the next problem. So here an Ogee weir 5 meter long has a head of 40 centimeter of water. If CD is 0.6, find the discharge over the weir. Okay, so the weir here given as a Ogee weir, Ogee shape weir. Weir will be like this. Okay, you know it is a Ogee shape weir. It will be like this. This is the Ogee shape, and the water will be falling like this. 5 meter long means the width of the Ogee weir. It's a 5 meter long, has a head of 40 centimeter. This is a 40 centimeter head. CD value is given, the length of the weir is given 5 meter. Head of water is 40 centimeter, 0.4, and CD is 0.6. As we know the equation for Ogee weir, that is the flow over the Ogee weir is similar to rectangular weir, hence we need to apply the equation as same as rectangular weir. That is Q equal to 2/3 of CD into L into root of 2G H raised to 3 by 2, and all the given data you substitute in this equation, we get the final answer as 2.2409 meter cube per second, or Qmax. Okay, so please check the answer. Okay, you can only thing you have to remember the equation, and for a Ogee weir, for the sharp crested weir or the narrow crested weir, the formula will remain same, that is similar to rectangular weir. Okay, only thing the broad crested weir, the formula get changes. There the characteristics of fluid flow will be different. Okay. Thank you. So similar kind of problems, you practice it and try to understand. Okay, I'll wind up here. Next class we'll discuss about Ogive sand. We'll discuss about one more type of weir in the next class. Okay, thank you.